Hi there, and welcome to Ian's Engage channel. I'm Ian. In previous videos, I've shown how I've modified the track plan to accommodate the possible use of Pico's Code 55 fine-scale track system. In this video, I'm going to show some of the experiments I've performed to enable me to decide whether to go with Code 55 for Shelfington or to stick with the Code 80 track that I was more familiar with. Up until this point, I'd had no practical experience working with Code 55 flexible track, so it was easy to assume that it was identical in nature to Code 80 flexible track, only with a lower rail height. In fact, for those that don't know, Code 55 track has the same rail height as Code 80 track, only the rails are embedded more deeply into the sleeper webbing, giving the impression that the rails have a lower profile. So this must definitely mean that Code 80 and Code 55 flexible track were essentially identical to work with, right? Well, no, they weren't identical to work with at all. The first time I handled Code 55 flexible track, I noticed that it felt quite different to its Code 80 counterpart. It felt stronger and somehow less flexible. I think this was a consequence of the rails being embedded lower in the sleeper webbing. Where Code 80 track could be bent and shaped freely in pretty much any direction you wanted, the Code 55 track offered much more resistance. Code 55 track was also much more difficult to bend in one direction than the other. With Code 80 track, there were cuts in the sleeper webbing that were offset beneath both rails. The Code 55 track only had cuts in the sleeper webbing below one rail. Having worked with Code 80 flexible track previously, I found its flexibility to be a double-edged sword. While it was great being able to easily shape the track, I'd had problems with keeping the rails in their chairs while trying to make short curves. I'd also encountered problems with the track wanting to spring back to being straight again, which was annoying when trying to temporarily pin it to my foam base, as it had caused the pins to tear through the foam on more than one occasion. The good news was that after only 5 minutes of playing with the Code 55 flexible track, it seemed that neither of these things would be an issue. However, I needed to convince myself, so I devised an experiment to help me come to a decision. I decided to make a small track plan that would replicate most of the situations I'd run into when working on the main layout. You can see here that the plan involves two main lines, with a crossover between them and a siding coming off the upper line. I've also included a curve with a short straight section, as I was keen to see how difficult it would be to create. The track plan was fairly simple, yes, but as it contained all of the elements I'd come across when implementing Shelfington for real, I was confident that it would help. Not only would it allow me to test how easy it was to bend both short and long sections of track, it would also test me on whether I could cut very short sections of track to length. It would also allow me to test how well the track would keep its shape while pinned to the foam, and whether or not the rails would remain in their chairs. So here's how I got on. The first job was to transfer the track plan onto my chosen baseboard, which of course was XPS Foam. I'd be laying the track on Cork eventually, but for the test I was going to lay the track straight onto the foam. So I went through my usual process of printing the track plan, cutting off the left and top sides from each page, then sticking the sheets together using sellotape. I printed out the plan with track centre lines and track section ends marked, which would help me when it came to transferring the track plan to the foam beneath. I pinned the plan down to the foam so that it wouldn't move around. Then the next stage was to poke a pin through the track plan at various points along the centre lines, ensuring that the pin also punctured the surface of the foam. As you probably saw, I started out making far too many holes, but quickly figured out a more sensible spacing. Once I was confident that I'd made puncture marks along all of the required lines, I removed the paper track plan and was left with a plan laid out as a number of holes in the foam. The next step was to use a magic marker to join the dots until I'd transferred the complete track plan. Okay, so I was now ready to start laying track. Or was I? One thing I'd been keen on for quite a while was creating custom track setter type templates that I could use to shape the flexible track to the exact shape required. While track setters were good, they came in quite limited shapes, so I used Inkscape, the free vector drawing application, to create a custom set of shapes tailored for this track plan. I then used my Cricut machine to cut out the shapes from 2mm Greyboard. As you can see, they fit the centre lines perfectly, and obviously the gaps are where the points will go. So, I was now ready to start laying track, wasn't I? Well, yes I was. I decided to begin laying the track by positioning the unifrog points. The points came with a longish wire that could be used to power the frog if required. As I wasn't going to do this, I decided to trim the wire, leaving a small portion of it tucked beneath the sleepers that I could solder to should I change my mind later. Once I'd trimmed the wire of all 3 points, I began positioning them on the baseboard in their designated positions. I'd ultimately be gluing the track down, but for this test I decided to use staples to keep the track pieces in place. These are Type 90 staples, and I've broken the individual staples from the strips using pliers. Each staple is 19mm long and spans just under 6mm, which fits nicely around a sleeper. I found that these are much better at holding down the track than track pins, which have a tendency to tear the foam over time, meaning the track will move, which can cause running issues. I began laying the track with the crossover points, placing them in their allotted positions and fastening them down using the staples over the sleepers on the outside edge of the track. Adding rail joiners used to be my least favourite job, other than using a jigsaw, of course. However, since obtaining the superb Westhill Wagon Works rail joiner mates, adding fish plates is no longer a frustrating or painful business. Once the crossover points were fastened down, I started working on the main lines. I began by measuring the track to size, then cut it using my Xuron track cutters, before removing sleepers at the end of the track to make space for the fish plates. The Xuron track cutters usually make a lovely clean cut, but on occasion, such as this time, they can leave a little metal burr on the rail. This can easily be cleaned up though using a small file. I completed the track join by pulling the rails along into the fish plates that were attached to the adjacent piece of track, using a pair of pliers. Now, unfortunately, just as I was about to tackle the small piece of track between the points, my camera battery died, and I didn't realise until I'd laid the remainder of the point system, which is so annoying as it was an incredibly infuriating process. What you're looking at is a shot of the track once it's been laid, and the sharp-eyed amongst you will notice that the small piece of track between the points is a little longer than the 20mm I'd designed it to be. This is because by the time I'd removed the sleepers from each end to fit fish plates, I was left with only one sleeper in the middle of the track, and unfortunately this wasn't enough to stop the rails from separating. So I extended the straight from 20 to 30mm, which gave enough room for 3 sleepers in the middle, along with the rail joiners at each end. Thankfully, I'd installed a new battery into the camera by the time I added the curve to the baseboard. This involved roughly bending a piece of track to the centre line and measuring it between the endpoints. The track was then cut to length. Once cut, the track was once again offered up along the centre line. And the outside rail pulled through the sleeper chairs so that it aligned with the inside rail. The sleepers could then be cut off to make space for the rail joiners. staples were then used to fix one end of the track to the baseboard, while the track was bent around the centre line again and the first template positioned between the rails. Once the template was in place, more staples were added to hold the track in position. I then repeated the exercise for the second half of the curve. I found curving the Code 55 flexible track to shape to be just as simple as using Code 80 track, with the added advantage that it held its shape much better and didn't want to continually spring back straight again. And with the templates helping out, it was a much less frustrating experience than I was expecting. Once the track had been laid, I cobbled together some wires and attached them to the track using crocodile clips. The way that the rails of the unifrog points were connected on the underside meant that power only needed to be supplied at one end of each of the main lines and the siding, as unlike insulfrog points, all entry and exit lanes were powered, whichever way the point was switched. To power the curved section, I used jumper leads from the lower main line. So, would this Heath Robinson approach to wiring work? Well, let's find out. Of course, the first loco to give it a go was my ever dependable Dapple Class 33. As far as I was concerned, this was the gold standard in N-gauge loco engineering, and was my go-to loco for testing all of my track work. I was incredibly pleased to see it traverse the track without encountering any sort of problem, not even stuttering once. I put this down to my incredible track laying skills. Haha! Next, I tried one of my Hunslets along the curve. This was essentially a third radius curve with a very short 17mm straight section interrupting the flow of the curve. It was nice to see the little loco coped with the curve despite it not being the perfect radius. More of which later. Next up, I tried the tiny Hunslet across the points. I was interested to see how the tiny wheels of my smallest wheelbase loco would get on when they encountered the unpowered frog of the medium radius unifrog points. In fact, I was over the moon with the performance. This was about the fourth or fifth time I'd ran the loco through the points, and other than a couple of stutters, there hadn't been any serious issues. However, with everything going so well, on this traversal of my test track obstacle course, there was a problem, with the little loco stalling twice in quick succession. Oh well. From my smallest wheelbase loco, I then tested one of my longest ones, and tried traversing the points with one of my Class 37s. I was obviously very interested to see how the bogies would interact with the unifrog points. As it turned out, the points and loco got on famously, with the loco traversing each and every point on the small test track multiple times and without encountering any issues. Now, I've only shown 3 of the locos I tested with in this video, but I actually ran all of them, other than my Class 08 as I haven't fixed its pickup issues yet. Overall, I've been delighted with how they all performed on the test track, especially with the smaller wheelbase locos such as the Hunslet and the Class 03. Okay, so I thought I'd say a quick word about the Greyboard templates I created. On the whole, I thought they were a success, although there was an issue with the longer curved ones. Unfortunately, as they sat between the rails, they would bend slightly along with the track, meaning if you weren't careful, they didn't hold their shape. This was most evident on the curved section of track here, where you can see that the track is offset from the centre line, despite me showing earlier that the template itself was a perfect match. However, the shorter curved templates didn't suffer from this problem, and did a much better job of aligning the track. I wondered if a coating of superglue would make them stiff enough to prevent them from bending, or whether soaking them in PVA glue would work. More experimentation required, I guess. Of course, I could just use multiple short templates to do the job instead. So, after all of this testing and practicing, have I finally come to a decision about using Code 55 track? Well, yes. Yes, I have. I'm going to go with it. Yes, you heard it here first. Shelfington will be constructed from Pico Code 55 Fine Scale track. Hurrah! Okay, so that's about it for this update. Have I made the correct decision to go with Code 55? After seeing my initial attempts at working with Code 55, have you any advice on how I could improve my track laying skills? Also, would you like me to make a video showing how I create the templates? Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a beginner in Engage modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. That just leaves me to say thanks very much for watching and Merry Christmas. Hopefully there'll be one more video before the new year. Bye.